Good morning. Today we are going to be adding mixed numbers. Okay, this is chapter 9, lesson 6. I will be doing this tutorial and Mrs. Smith will be making the subtracting mixed numbers tutorial. Okay, so when we're adding mixed numbers, we are adding whole numbers, 1 plus 3, 4 plus 2, but we're also adding fractions. Okay, the idea of a mixed number is that it is a number that has a whole number and it also has a fraction. Okay, we are going to be assuming that all of the fractions that are being added have the same amount of pieces, right? Or they're going to have the same denominator when we are adding. When we have the same denominator and we're adding fractions, no problem, very cut and dry. Add the numerator and then keep the denominator the same. And I'm going to show you what to do with the whole number. Okay, so we have a problem such as 3 1/4. Okay, what if we added another mixed number to this and we added 2 2/4? Okay, first off, we see the fractions, right? We see that we are going to be adding 1/4. Right? And eventually we're going to add 1/4 to 2/4. Okay. So what do we do with the whole numbers? Okay. When we are looking at a mixed number, we are assuming that in order to make each one of these whole numbers, we had to have 4/4. 4/4 makes one whole. Okay. So if we have 3 wholes, okay, we know that we have 1 whole plus 1 whole plus 1 whole plus our fraction, right? So 1 plus 1 plus 1 is 3. There's your 3. And then plus the 1/4 is your 1/4, making 3 1/4. Well, with these whole numbers, how did we make these whole number ones? Well, because our denominator is 4, right, we had to get 4/4 to make that 1 whole, plus another 1 whole, which is 4/4, plus another 1 whole, which is 4/4, plus our 1/4. Okay, these two representations mean the same exact thing. They are simply just represented differently. Okay, so this equals our 3 1/4. Sorry, this equals our 3 1/4. This also equals our 3 1/4. Okay, now we have this 2 2/4. Okay, so how did we make the 2? Well, 1 plus 1 is our 2 plus, well, our 2/4. But because 2/4 is not a unit fraction, how many fourths did we have to add together to make 2/4? Well, 1/4 plus 1/4. What we are doing is decomposing this mixed number. Okay, we are breaking it up into its unit parts. Unit means 1. Okay, so let's look at the opposite way of representing this, where we use the fraction that represents that 1 whole. Again, it's in fourths, so in order to make that 1 whole, we had to have 4/4 plus 4/4 plus our 2/4, which is 1/4 plus 1/4. Okay, now if we add all of those up, you have 1, 2, 3 whole numbers plus a 1, 2 more whole numbers. That is your 5. Okay, and then we add our 1/4 and our 1/4 and our 1/4. That gives us 3/4. Okay, also we could add 4/4 plus 4/4 plus 4/4 plus 1/4. 4 plus 4 plus 4 is 12. Yeah. Plus 1 more is 13. Plus 4 more is 17. Plus 4 more is 21, 22, 23 fourths. Now, we have our answer in two forms. We have 5 3/4 and 23 fourths. 23 fourths is what you call your improper fraction. That's the fraction that has a numerator that's larger than our denominator, and it's called an improper fraction because a fraction, by definition, is a part of a whole. And if we have 23 fourths, we have more than just a part of a whole. In fact, we have multiple wholes and a fraction. Okay, so that's why they call it an improper fraction. It's not really a fraction because it's not a part. It's a mixture of all of our whole numbers and our fractions. Okay, so we have 23 fourths. So if we did this, right, and we had a rectangle and we broke it into fourths, all right, there we go. That's 4 fourths. And we'll do it again. That's 8 fourths. Do it again. 12 fourths. And again, 16 fourths. And again would give us 20 fourths. And then we have one more because we got to make 23. Now we have 24 fourths. So let's shade these in, and you can see how we have more than just a fraction when we're dealing with 23 fourths. We have all these wholes, 4 fourths, 4 fourths, 4 fourths, 4 fourths, okay, equaling one whole. So we have 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6, 7, 8 fourths, 9, 10, 11, 12 fourths, all right? We're almost to 23 fourths, 13, 14, 15, 16 fourths, and we have 17, 18, 19, 20 fourths, okay, almost there, and then our 21, 22, and 23 fourths. Goodness gracious. We've got all these whole numbers, and then we have our fraction. Therein lies the mixed number. So we have 4 fourths, that's one whole, another 4 fourths, another whole, another 4 fourths, another whole, another 4 fourths, another whole, another 4 fourths, equaling 1, 2, 3, 4, 5 wholes. That's where the 5 comes from. And then our 1, 2, 3 fourths. We add all those together, we get 5 3/4, which is our mixed number and which is the way that we need to represent all of our answers when we are working with these kinds of problems. When we are adding mixed numbers, we don't want to end up with an improper fraction, okay? It's kind of like it's putting your fractions into simplest form by taking an improper fraction and turning it into the mixed number that it really is, because it's not a fraction. It's a mixture of a bunch of wholes, in this case 5 of them, and our 3/4 of a fraction, okay? So by the time we're done with each one of our questions, we should end up with a mixed number if our fraction is improper, okay? So let's get to the lesson. I should say let's get to some examples. Alrighty, let's take a look at Mr. Word problem number 15. In fact, this will be the example that I do. Mrs. Schnett's class and Mrs. Smith's class, I believe your independent practice is your assignment. Mr. Tillish's class, your assignment is the homework page. And really that is just a miscommunication by Mr. Tillish. I was assigning the homework pages. and Mrs. Smith is assigning, and Mrs. Schnetz's class is assigning the independent practice. Okay, let me know if you have questions about that. So in looking at an example here, I do like to use the word problem. So Mr. Schnetz, Mrs. Smith, I'm sorry about this, but I am going to take one of your word problems, and we're going to talk about our good friend Brennan. Brennan ate 2 1/4 apples. Okay, so that means he ate 2 whole apples and was like, Mom, I'm going back for more. I want to eat another one, and couldn't quite eat that third one, and he only ate 1/4 of it. Then he ate another 1 2/4 apples the next day. Okay, so essentially he ate 1.5 apples the next day. How many apples did Brennan eat altogether? Write in simplest form. Okay, so that's that clue that you're going to end up having to put an improper fraction, turning it into a mixed number, and put it into a mixed number. Okay, so our cube says to circle the numbers. Let's underline the question and box those clue words all together in simplest form. Okay, we're not done until we put it in simplest form. And because it says all together in the problem, we are going to be combining the 2 amounts of apples that our good buddy Brennan ate. So let's take a look. We had 2 1/4 apples. Okay. And then we had 1 2/4 apples. So essentially, in order to have 1 1/4 apples, we had 1 whole apple plus 1 whole apple plus another 1/4 of an apple, or 1/4 of an apple. The other way to represent that is by how did we make the wholes? Look at your denominators. It's a 4, so you had to have 4/4. Okay, Mom cut that apple up into 4 slices and he ate it. Mama cut up another apple into 4 slices and he ate the whole thing. Mama cut that third apple up into 4 slices and he only ate one of them. Okay, so 2 representations of the same idea of how we got to 2 1/4. Okay, now let's take a look at 1 2/4. We have 1 whole apple plus 2/4 of another apple. Okay, the other way to write that is, how did we make the whole? Okay, how many fourths did it take? Well, it took 4/4 to eat that 1 whole apple on that next day. And then to eat the 2/4, Brendan had to have eaten 1/4 of it plus another 1/4 of it. All right, so that is how we made the 2 mixed numbers, 2 1/4 and 1 2/4. So let's take a look here. 1 plus 1 gives us our 2, plus 1/4 gives us our 1/4. Okay, 4/4 plus 4/4 plus 1/4. This is your improper fraction. Okay, 4/4 plus 4/4 plus 1/4 gives us our 9/4. 9/4 and 2 1/4 are the same number, okay, represented differently. One's represented in an improper fraction, the other one's represented in a mixed number. And then we have, for 1 2/4, we had 1 whole apple plus 2/4 is how we made that 1 2/4. Or to create the improper fraction, you have 4/4 plus 1/4 plus 1/4, and that gives us your 6/4. Okay, now what does all of this mean? Well, 2 1/4 plus 1 2/4, we can add that up over here. 2 plus 1 is 3. Keep your denominators the same. 1 plus 2 is 3. All together, Brennan ate 3 3/4 of the apple. Okay, 3 3/4 of apples between both days. Now let's take a look at the improper fraction. We have 9/4 plus 6/4. Okay, 9 plus 6 gives us 15/4. Okay, now when we have 15/4, we have an improper fraction. We have a mixture of whole apples and that part of the apple that he ate on both days, the 2/4 and the 1/4. So let's deal with fourths. We'll draw our picture. This is checking to make sure that we are on the right path here. So I'm going to draw 1, 2, 3, 4. 1, 2, 3, 4. One, 2, 3, 4. So we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Trying to make our 15. 9, 10, 11, 12. Oh, we need some more fourths. 13, 14, and 15. So in looking at our 15/4, we have 4/4, which is 1. Another 4/4 is 1. Another 4/4 is 1. And then we have our 1, 2, 3/4. You add those together, you got 1, 2, 3, and 3/4. Okay, so this is the long, drawn out explanation of why. Okay, why do mixed numbers look the way they do? Why are mixed numbers mixed numbers? Why are improper fractions improper? All these little icons are just getting in the way. So now let's take a look at one more problem as we write the answer down to 15. 3 3/4 apples were eaten all together. And that certainly could have been worded better, like Brennan ate 3 3/4 apples all together. Okay, so make sure that we are trying to use the question in our answer, as Mr. Tillers clearly did not do in that example. Okay, all right, let's take a look at number 16. Again, sorry, Mrs. Smith, Mr. Schnetz, I'm going to use your word problems here. The bakery shop purchased 7 2/10 pounds of sugar and 7 5/10 pounds of flour. How much sugar and flour did they purchase in all? Well, the algorithm says, the shortcut says, let's add up our numbers. Let's stack our mixed numbers. 7 2/10 plus 7 5/10. And if we add those two together, I stack them on top of each other. Seeing this stack when I was a child was a source of fear. But I think that the way that we're explaining it today, I think you're going to be very successful with this. So let's add it up. Our 7 plus 7 are two whole numbers. That gives us 14. That's a massive mixed number. And then our denominator stays the same, 10. And we add up our numerators. 2 plus 5 is 7. 14 7/10. Okay? So that is the easy way of going about and adding your mixed numbers, right? Add your whole numbers first, and then add your numerators. Keep your denominator the same. You end up with 14 7/10 pounds of sugar and flour purchased all together. Okay, but if we break these up, okay, if we break these up into their individual pieces, it would be 7 2/10 is 1 whole plus 1 whole plus 1 plus 1 plus 1 plus 1 plus 1 plus our 2/10. Right? That's 1 whole 7 times plus our 2/10. And then we have the version of how did we get 1 whole? Well, the idea is that this entire mixed number knows a whole number. It's all dealing with tenths. Okay, so we have 10 tenths, 10 tenths, 10 tenths, 6 and 7, 10 tenths 7 times, plus 2 tenths, which is in unit fractions, 1 tenth plus 1 tenth. Okay? And then we add up all those tenths, right? 72 tenths. 72 tenths. And then we do our 10 tenths, 10 tenths, making our 7 tenths again, or our whole number 7. That's 4, 5, 6, and 7 tenths plus our 5 tenths. That's our 1 tenth plus 1 tenth plus 1 tenth plus 1 tenth plus 1 tenth. Okay, that is 7 and 5 tenths decomposed, broken apart into its bits, right? 10 tenths of that apple, 10 tenths of that apple again, or those pounds of sugar and flour, right? So we end up here with 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74, 75 tenths. Okay? Now, you would draw a picture of this to represent the layout of all of your tenths, right? This is going to be a long list of tenths all the way down, okay? But if you remember to take a look at each one of your example problems that you have here, and you stack them on top of each other, add your whole numbers, and then add your fractions, you're going to do okay. Here at the bottom of your independent practice, Mrs. Smith, Mr. Schnetz's class, this is where you're going to need the skill of your unit fractions, okay? How each one of the mixed numbers is decomposed. So 2 and 2/5, right? Which one of these decomposed versions equals 2 and 2/5? Make your 2 with your 1 plus 1, okay? And then you make your 2/5 with your 1/5 and 1/5. Which one looks like that? And then you have 14. 13 and 14 both have the representations with the 8/8 and the 2/2, okay, to represent your whole numbers. Okay, so please refer back to this tutorial if you have questions. And good luck, Mr. Tillish's class and Mrs. Smith and Mrs. Schnetz's class. Mr. Tillish's class, this is your assignment, okay? 597, 598. Mrs. Schnetz and Mrs. Smith's class, 595 and 596, okay? All right, ladies and gentlemen, you guys go ahead and take care, and we will be talking at you soon. Thank you very much.